Welcome to my YouTube channel. Okay, this is your teacher and honest, commonly known as Mr. A Plus. Okay, so today we are going to look at how to differentiate the trigonometric functions. As you can see, we have that one on the body. Yes, so when I say trigonometric functions, I simply mean the functions like sine, cosine, tangent, cot, cosec. Those are the things that I'm talking about. So now let us see how we can differentiate sine x. Yes, sine x. For us to differentiate sine x, we are going to use first principle, because there are different methods that you can use for you to differentiate certain functions. Okay, so now in this case, as I mentioned earlier, we are going to use the first principle. Yes, so the first principle states that f of x prime is equals to lim as h approaches 0, f of x plus h minus f of x over h. Okay, so that is the formula for first principle, and that is the one we are going to use for us to differentiate the given function. Okay, so now what has just remained, since you have introduced the formula, we are now going to substitute according to the function that we are given. Yes, so we are saying lim as h approaches 0. So here we are going to write sine, open bracket, x plus h, close, then minus sine x, okay, over h. Yeah, so now that we have substituted according to the question there, here I'm sure you can remember when I take you back to the additional formulas. So now we are going to expand this one according to those additional formula that we have. So we are going to say, how do we expand that one? Lim as h approaches 0. This is sine x cos h. Okay, here the operating sign is positive or plus. So that's the one we are going to maintain. Then we have cos x sine h, okay, over h. Yes. Okay, let us not forget we are still a further function there when we underline like this. So let me put h at the center there. Okay. So now from there, what we are going to do here is actually factorize the given function that we have. Okay, so as you can see here, we have this term which is sine x. Then this side we also have sine x cos h. So we are going to rearrange them in that direction. Then thereafter we are going to factorize, okay, for us to simplify further. So what am I trying to say? I'll bring this one down. Okay, lim as h approaches 0, we have sine x cos h, then minus sine x sine x, okay, Then this side we have plus cos x sine h. Okay, then over h. Okay, so I'm sure here now we can actually simplify. We can simplify this one by factorizing. What is common here? Here we have sine x, which is common, which is also here. So we are going to say sine x will be outside. There we remain with what? Cos h, then there minus 1. Okay, then plus. Remember here we still maintain what we have. There we have cos x sine h. Then over h. Over what? Over h. Okay. So now from there, we can write this fraction as, we can separate them since we have here addition. So we are going to separate them. Remember, this denominator we have here caters to the both terms, this one and also this one. So this one can be written further like this. So we are saying here we have sine x open bracket cos h minus 1. Okay, we can say over h for this one, then plus cos x sine h over h. Okay, so that is the way to go. We have just separated them. Okay, they are just one and the same. So now from there, we are going to write this one as sine x. Then that one cos h minus 1 over h. Then plus this cos again be here cos x. Then on top we are going to put sine h over h. Okay, so you have seen the way we are moving. Then now from there we'll get back to limits. Okay, on limits, if you go back to limits, cos h minus 1 over h is actually 0. So here we have 0. All this thing is equal to 0. That's what the limit states. Then from there, plus cos, we have cos there, cos x. So sine h over h is equals to 1, according to limits. Okay? That is only observed if you have more ideas about the limits, where we use the hospital rule for us to replace those values, so that we can come up with 1 inside 0. So whenever you have this in trigonometric, when you are differentiating using base principle, just know that this is 0, that one is 1. Okay, so now from there we can simplify further. How? We are going to multiply sine x times 0 automatically to give us 0, plus then cos x times 1 to give us cos x. Okay, 0 plus cos x is cos x. Okay, therefore when you differentiate sine x, the result that you get is cos x. Okay, thank you so very much for following. we have just come to the end of our question that we have. Thank you.